Hey guys, today we're going to continue our discussion of equations, and we're going to do that with something called literal equations. And a literal equation is essentially an equation that has multiple variables in it. And I think at first sometimes this feels like a brand new thing and it can be a little bit stressful, but I want to show you in the next couple of minutes that it doesn't have to be stressful. It can be just as simple as solving any other equations that we're used to solving. So an example of a literal equation would be something like ax plus b equals c. And of course, this looks a little bit different, or a lot different than what we're used to seeing because there's no numbers in there. It's very difficult kind of to wrap our head around what exactly I'm going to ask you to do when there's no numbers. So one of the big differences in a literal equation, unlike a regular equation, let's say something like 2x plus 5 equals 15, is that in the regular equation over here, in an equation we're used to seeing, it's very obvious what we're trying to solve for. There's only one variable. We're trying to figure out what x is equal to. In the literal equation, there's a lot of different variables. So one thing that's a little different about a literal equation is we're always going to tell you what to look for. So I might say something like solve for x. And the question would be a little bit different depending on what I've asked you to solve for. So in this first example, we're going to solve for x. And we're going to use our equation over here on the right-hand side of this guy once again. We're going to use that guy to help us figure out what to do with our equation on the left. So on the right over here, we have 2x plus 5 equals 15. And how would we go about solving that equation? So certainly we would subtract 5 from both sides. And we would end up with 2x equals 10. And then we would divide by 2 on both sides and get x equals 10 divided by 2, which is 5. And that's a pretty easy question for most of you. We're pretty comfortable with two-step equations. Well, the equation over here on the right is also a two-step equation. So we're going to use our model on the right to help us out with our literal equation over here on the left. So in the question on the right, the first thing we did was we subtracted 5 from both sides because we knew that we wanted to get this 2x all by itself. So since we're trying to get the x by itself on the right, we're going to try to get this ax all by itself. And what do you think I could do to get rid of that plus b? So we're going to go ahead and subtract b on both sides. And the b's are going to cancel. B minus b is, of course, 0. And I'm going to bring my ax straight down. And over here, I have c minus b. Now, we were going to remember that c and b, those are not like terms, so we can't really combine them. All we can do is write c minus b. And then, since we're trying to solve for x, over here on the right, we divided by 2 to get rid of that 2. So on the left, in a literal equation, what do you think we could do to separate the a and the x? Yeah, so we're going to go ahead and divide by a on both sides, and then the x is going to be by itself. And we end up getting an answer that looks like x equals c minus b over a. And that's my final answer. That's the best I can do. There's nothing I can do to combine that a and that b and that c in any way because they're all different variables. And so I'm stuck with x equals c minus b over a. Cool. Let's try another example together. So what if we're looking at something like, let's do a over n minus q equals r. And like I told you before, there's a lot of variables here, so when I give you a question like this, I'm going to have to tell you what to solve for. Well, I want us to solve for a. I want us to try to figure out what a is equal to. So the first thing I'm going to do, I need to get this a over n by itself, so I've got to get rid of the minus q. And how do you think I'm going to get rid of a minus q? Right, so I'm going to add q to both sides. And a minus q and a plus q are going to go away. They're going to cancel each other out. I'm going to bring my a over n straight down, and I'm going to say that's equal to r plus q. And then what? What can I do about the fact that right now there's an n on the bottom of this a? What do I do to get rid of that over n? Right, so the way we get rid of divide by n is times n. We're going to multiply both sides by n. And that's going to give us a equals n times r plus q. And that would be a very okay place to end your answer. That's pretty good. That's a really nice answer. I want you to think for a moment, though. Is there any other way that I could write that answer? There's nothing wrong with writing it this way, but is there any other way? Think about that for a moment. And of course, the answer is yes, there is. I can always, instead of writing n times r plus q, I could always distribute that n and end up with a equals rn plus qn, something like that. And that would mean the exact same thing. Cool. So I'm going to put one more example up here in our introduction to literal equations. And I'd like you to try to solve this one entirely by yourself. You're going to submit your answers back to me as some feedback, and then we'll take a moment and I'll go through the question to make sure that everyone is on the same page. So we're going to try x plus n over L equals W. And I want us to solve for n. Solve for n. And I know this might seem a little overwhelming. We've only done a couple examples, but I want to see who kind of got this right away. So give this question a try, and then we'll come back and talk about it. Cool. So let's give it a look. We've got x plus n over L equals W. And I'm trying to get this n all by itself. But right now, I've got this L hanging out down here, that L right there, and it's stressing me out. It's making this question look different than some other questions we've done in the past. So what can I do about that divide by L? Right, we're going to multiply by L on both sides. And on the left, my L on top and my L on bottom are going to cancel, and I'm going to be left with x plus n equals WL. Now, this is where we want to be very careful. What did I ask us to solve for here? I asked us to solve for n and not for x. So in your work, if you turned around and subtracted n and you got x equals WL minus n, well, that's true. X does equal WL minus n. But that's not what I asked you to solve for. What I specifically asked you to solve for was n. So I'm going to take a couple steps back here. And instead of subtracting n, since I want to get n by itself, I'm going to move the x instead with subtraction. X minus x cancels, and we get n equals WL minus x. And if you got that, that's awesome. You're well on your way to understanding literal equations. And if you're not quite there yet, you know it's okay, because you know we're going to spend some time in class tomorrow figuring it all out. All right? So have a good night, guys, and I will see you guys tomorrow.